Now, we didn't document our code in the previous part of the project because it got a bit messy, and I have prepared a very well documented code in the source code file section of the course, so when you download it, the file that you will get will be documented. Now, one last thing I want to show you, which will be a small introduction to a project that I will leave you tackle on your own. Dividing your image into squares and flipping it. Now, before we proceed, you will need conditional statements and loops to be able to finish it in its full form. But the part that we will do now does not require loops and conditional statements. What we will do is take an image, divide it into 4 squares, and then reconstruct it and rearrange it. This task is easily accomplished, and there are 2 main things we need to do. First, you need to correctly extract the 4 parts and then concatenate them correctly. Let's first get our image. So image imread test1. Let's use the other image this time, .jpg. Let's visualize it. show image, run. Alright, this is the other image that we're going to work with now. So what we have to do is simply split the image into 4 corners. We have to extract each of these corners into separate matrices. So let's think about extracting these parts. First, we will start with the top left corner, with this corner. We need to divide our image into halves, a width half and a height half. So this is the height half and this will be the width half. So we need to get the values for half height and half width. The half height will be the size, the first size of the image divided by 2, and the width is size image 2 divided by 2. Now, the problem here, just like when we did with the grayscale image, we get floating point numbers when dividing or taking a square root. We have to floor this value, floor it, and floor it here too. Right, now we need to take the top left corner. How are we going to do this? We're going to take the image and let's open the image. So we are taking the image. The top left corner starts from index 1 and 1. So both rows and columns will start from 1. And the rows will be until we reach the half height. And the columns will be until we reach half width. So 1 to half height and 1 to half width. Just like that. Now let's try and visualize it. Figure show of top left. It should work. Alright, it works, but we got only a grayscale image. Why did that happen? This happened because we didn't select the colors. So we want all colors. That's why we are going to use the colon operator. Run it again. Alright, there we have it. We get only the top left corner, so we are somewhere around here and down here. Great. Now let's take the other corners, the top right corners. The top right corner will be image. The top right corner also starts from the same height. It also starts from the first row until the half of the row, so 1 to half height. But its columns start from the half width plus 1, because we end at exactly half width here. So half width plus 1 until the end. So half width plus 1 until the end, all colors, everything in the third dimension. Let's visualize this one as well. Figure show top right, run it. Alright, we get the second half. Very good. Now let's get the other halves. The other halves will start from half height, so from the middle of the rows until the end, plus 1 again. And the columns will be from 1 to half width. So bottom left equals image half height plus 1 until the end, and 1 to half width and all colors. And let's do the bottom right. So image, The bottom right will again be half height plus 1 until the end, and here we will get half width plus 1 until the end, and all colors. Now, we can visualize all of these images, but what I'm going to do is I'm simply going to concatenate them. So, reconstructed image. Let's reconstruct the image. Reconstructed image equals. We're going to concatenate the top left and top right corners horizontally, and we're going to concatenate the bottom left and bottom right corners below the top corners. So, top left, top right, bottom left, bottom right. Let's run it, and you can see that we get the exact same image. If we even take a look at the sizes, the image is 900 by 900, and the reconstructed image is also 900 by 900. So it's working. We can flip the image, so we can rearrange it. So flipped image. We are going to put the bottom right corner in the top left spot. So bottom right, bottom left, top right, and top left. And let's visualize it. Flipped image, run. There we have it. Wow. Again, the same size, but now the top left corner, this corner here, is now bottom right corner. So we have switched them diagonally. Now, the project that I was talking about is something that I did long ago as an exercise. The idea is similar to what we just did, but the scale is bigger. That's why you would need to use conditional statements and loops that you will learn in the next sections. The idea is to first take either rows or columns. So let me first show you actually what it does. So I have created it in a function file, which you will also learn how to do in the next sections. So I am flip, and I will give it an image. So test JPG, run it. Now here we have an image. Let's open it outside MATLAB as well. So this is our image, and this is what MATLAB does with the image. As you can see here, we have a nice image of some galaxy, but here it's pixelated. It has big squares. It's not really pixelated, but the idea is the following. First we take either the rows or the columns. So we take either the columns. So let's say that we take the columns. We take the first and the second column and we switch them. So the second column becomes the first becomes the second. We do the same thing with the next columns, and we switch them until we reach the end. Then we take the rows, so first row, second row, and we switch them. So second row becomes first row. We do the same thing with all of the other rows. And these rows have a width of 50 pixels or 100 pixels. The width of these rows determines how big these squares will be. So you keep swapping rows and columns until there are no more rows, and that is how you end up with this effect. If we try it on another image, so let's use test 1. There we have it. We saw this image a bit earlier. As you can see, it's all squares that are swapped. There are a couple of things that you need to keep in mind here. First, you need to keep in mind that you must take into account the different sizes, and this is what makes it a bit tricky. If your image is 650 pixels wide, you have only 3 pairs of columns. If the width of the column is 100, you have the first and the second, the third and the fourth, and the fifth and the sixth. And at the end, you will have a 50 pixel column, which you shouldn't move. The same thing applies for the rows. Or what if it's a 500 pixels wide image? You have 2 pairs of columns, the first and the second, and the third and the fourth. Your last column, the fifth, is of the correct width. It's again 100 pixels wide, but you have no other pair for you. You don't have a sixth column, so you must leave it too. Usually tasks as these are not hard. The hard thing is taking into account all the special cases. So if you decide to try and do it, start with an image that is 600 by 600, since there are no special cases. Get it working and then worry about the special cases. Again, You need a bit more advanced knowledge than what we have learned so far, so once you proceed with the course and get to know loops and conditional statements, and if you want to challenge yourself, try and do this.